Viva voce examination is as much important as that of marriage. கிட்டத்தட்ட வந்து இந்த வைவா வாஸ் எக்ஸாம் அது ஒரு ரிசர்ச் ஸ்காலருக்கு மட்டும்தான் தெரியும். Because I have also guided near about 10-11 students. Some students used to be very casual and some students will be very much emotional. சில பேர் பார்த்தீங்கன்னா ரொம்ப எமோஷன் ஆயிடுவாங்க. So such a great event, the PhD Viva voce examination is a great event in any researcher's life. So the examiners have graded this thesis as a highly commended. Why don't you give your big hands? Because the work has not been done in the normal situation. The work has been done in a pandemic situation. சும்மா இருக்கிற காலத்தில் நம்ம ரிசர்ச் ஒர்க் பண்ணுறதே ரொம்ப கஷ்டம். ஏன்னா கேரக்டரைசேஷனுக்கு போகிறது, நிறைய பேப்பர்ஸை கம்யூனிகேட் பண்ணி அவங்க கொடுக்குற கமெண்ட்ஸை வந்து நம்ம ரெக்டிஃபை பண்ணுறது, தீஸ் ஆர் ஆல் த சேலஞ்சிங் திங்ஸ் in normal days itself. But we came across a crucial period, pandemic period. It taught a lesson to the human community how to lead the life. But even in that situation, Professor Ravidas sir has concentrated on research work and guided the students. So really it's a wonderful thing to appreciate him as a man who is really serving the student community. So based on the evaluation rating, grading of the examiner, and based on their reports, because they have appreciated well the presentation of the thesis, copper oxide shifted to lower wave number and manganese substituted copper oxide shifted to higher wave number.
So this is due to the size of the samples. Size of manganese is greater when compared to cobalt and nickel. So we have this shift.
The next is, on what basis the candidate prefers A549 as the targeted cancer cell for the application part?
Is that actually while doing antimicrobial activity, our sample is more efficient for pneumonia microbe. That is the microbes that cause disease in lungs. So we had an idea, why can't we move this to another level? So that's why we chose lung cancer, and the common cancer that arises in India is also lung cancer. So that's why because our sample is efficient towards the microbes causing lung disease. So that's why we chose that.
How does the author cite first order kinetics when the degradation percentage is not linear?
Yes, sir. Actually, we have to go for second order kinetics, but in most of the reports they have done first order kinetics. To make a comparative survey, we did first order.
And these are the questions raised by the examiners, and the candidate has answered correctly. And my own questions, one or two questions. Regarding the copper oxide nanoparticles, while doping the cobalt, manganese and nickel, did you not observe the secondary phase formation?
No, sir. No, sir. We never
How did you confirm that there is no secondary phase?
From the XRD pattern, sir, we compared it with the JCB discard value and we didn't get any extra peaks.
Then you said that there is no structural change even after doping. Is it?
No, sir, we got monoclinic structure for all the samples.
You got monoclinic
yes,
structure?
Sir, for all the samples.
What is the structure of undoped copper oxide?
That is also monoclinic, sir.
So there is no structural
yes, sir,
change.
Yes.
So what about the preferred orientation of growth?
111 and minus 111.
So even this preferred orientation has not changed even
Yes,
after
sir.
doping.
Yes, sir.
Okay, with this I can say that the candidate has answered all the questions of audience as well as the examiners. Now I request the guide, Professor Dr. C. Ravidas sir, to have the further proceedings and or to give me the suggestion to proceed further. Is the question that among the different transition metals, why did the candidate prefer to dope with the manganese, nickel and cobalt in copper oxide nanoparticles? Is there any correlation between the magnetic properties with the photocatalytic and microbial activity?
Yes, so there is a correlation. Actually, while choosing the material, we thought of choose copper, cobalt, nickel and manganese. Cobalt and nickel having ionic radius lesser than copper, and manganese having the ionic radius somewhat greater than copper. After finishing photocatalytic activity, we tried to retrieve the sample, but we couldn't take 100% of sample from the rhodamine B-type. So if we incorporate any material having magnetic property, then it is easy for us to retrieve the material from the rhodamine B type. For that purpose, we chose manganese as one of the dopant.
The next question is, did the candidate make any attempt to confirm the retainment of the exact composition observed during the preparation of C3N4 in copper oxide after multiple photocatalytic degradation cycles?
Yes, sir. We have done for 3 cycles. We have done for 3 cycles, and we have we have done XRD before and after the treatment, and the XRD pattern remains the same. Only we then that is a variation in intensity. So that is due to the loss of samples while retrieving it, sir. So we have done for 3 cycles.
What would be the scope of the present work in the degradation of organic dye mixtures from textile industries?
The scope is we can employ this in a large scale. For example, nowadays all the industries discharge their effluents in river water. So we can mix a sample in river water, and we can treat that water, and we can use it for irrigation purpose. So if we do this again and again, we could able to get pure water at loss, so that we can use for the utilization of human beings.
Then next examiner has asked a few questions. The candidate should explain the morphological evolution from aggregated grains to well-defined grains in the case of pH variation.
Yes, sir. At lower pH, due to the presence of the secondary phase, copper-based secondary phase, we couldn't get a regular shape. But while increasing the amount of hydroxyl ions, that is by increasing the pH, the formation of copper oxide is complete. That is, for one copper, we need 2 oxygen. So that is yielded by the pH of the sample. That is the NaOH added with the sample. So the particle size has been regular and well defined for higher pH values.
The author mentions COD and antibacterial activity, but why does not provide GCMS, HPLC and TOC?
Yes, sir, we thought of doing that, but during the end of my work, we were in Corona, and I couldn't find labs to do those studies, sir. So that's why. But that is the future work.
Okay. Why the Ram KC Mercy Jnanamala have suggested some questions to be answered at the time of examination. 3 examiners have evaluated. One examiner is a guide internal examiner, and 2 external examiners have evaluated and suggested some questions. Few questions will be asked. One of the examiner has asked the question, how did the candidate control the particle size distribution, agglomeration, and resultant yield of nanoparticles in the cobalt in the co-precipitation method.
Yes, sir. In co-precipitation method, to control the particle size, we have adopted a method. That is, we did the dissolving process in a chemical bath, and we included some temperature, and we'll be adding NaOH pellets to adjust the pH of the sample. So instead of adding NaOH pellet, we dissolved this NaOH pellet in water, and we added drop by drop, and we gave some time for nucleation process. So with this, we controlled the particle size and other parameters.
You had the control on the nucleation process.
Yes.
Thereby, you controlled the properties like particle
Yes.
size and agglomeration. And then, how did you prove that there is no agglomeration? How did you prove that?
By SEM analysis, sir. By SEM analysis, from the morphology, we have seen the differences between each and every sample and the agglomerations.
Another question is asked: why did cobalt substituted copper oxide nanostructures exhibit high antimicrobial activity compared to nickel and manganese doped copper oxide samples?
Basically, cobalt is having some biological activity, sir. And another thing is the ionic radius of cobalt is very much lesser than copper. So it will be well substituted in the Cu sites. So that's why the particle size has been reduced, and it is more efficient towards photocatalytic antimicrobial and.
So that substitution, how did you ascertain that cobalt has been substituted well in the copper oxide nano samples?
And, by seeing the shift in the XRD patterns.
Nice. Then another question is asked: what is the practical feasibility of the prepared copper oxide, transition metal doped, and composited nanostructures to treat different classes of effluents in textile industries, and especially the activity of prepared samples in direct sunlight?
We can do this, sir. We can take the industrial effluent from the industry, and we can perform photocatalytic activity. So here, in the present work, we have used a lamp, halogen tungsten lamp as visible light, and instead of that, we can keep it in sunlight for some hours, and we can measure the absorbance. And another method we can do this is, we can mix all the dyes. There are different colored dyes: methylene blue, rhodamanthe, Congo red, phenol, and so many dyes. So we can mix it all. So if we mix it all, it will be related, or it will be same as the industrial effluent, and we can try photocatalytic activities.
But your area is that one you have concentrated
Only
on
on
medical
drug.
field,
Yes, sir.
antimicrobial and
Yes, sir.
cancer activity.
Yes, sir. And we did photocatalytic for only for rhodamin B because majority of industrial effluent use rhodamin B. So all the effluents contain rhodamin B. That's why we chose that as sample type.
Okay.
Cobalt and nickel and one more component to add as a dopant. You said that cobalt mix in the it reduced 50% or something.
Yes.
What will happen when you mix together both cobalt and nickel and one more
Co-doping.
co-doping?
So we have to make a trial.
Okay, ma'am. Okay.
You can have the lead.
Yes,
Suppose
sir.
yes, yeah. You consider it.
Now we are doing it, sir. Our MSc student is doing it.
Okay, okay.
One more thing I like to get it clear. But the first dosage itself it reduces by 50% of killing of cancer cells. If the process is repeated, you think that it will prolong to reduce it down to zero.
Yes, sir.
Only
It is
when
down
you,
to zero.
yeah,
Yes, sir.
you have to
Because
go
we have
for
done only the
multiple cycles.
preliminary, only one cycle we have done.
So-
If we repeat this again and again, we could
Eradicate totally.
yes.
Because cancer cells will leave behind, a single cell will influence other cells
Yes,
to get
yes.
annihilate. That will happen. Thank you.
Thank you.
ஒரு ஸ்லைட் நம்பர் போட்டுருக்கோம். Good.